So we've scanned this wrench with the same Z-Corp scanner used in the video, and we're going to walk through the process of building a model. Now, why do you need to build a model from the 3D scan? It's a little bit like scanning a document. You can either capture a JPEG of the document that you can't edit or modify, or you could try to convert it into a Word document where you can modify the text, change it, fax it, email it, etc. So the differences are very similar with scanning. If you have an object like someone's face or a toy or something like that, where you just want to capture all of the outside shape, you can print that very easily just as it is, because you just want to duplicate what you observe to be the case. In this case, with this wrench, we want this to actually perform a function and to be mechanically sound. And so that's going to take a little bit extra work to get a perfect result when we go to printing. So, as you can see, we've got the scan here, and we only scanned 1/2 of the part. And we also didn't get very much information in the thumb screw, and there's areas that are hidden inside of the part. These are traditional limitations to any kind of measurement process. If you can't reach or touch the area you want to measure, it's going to be very hard to come up with the information for that. So the first thing that we'll do is remove a lot of this extraneous information, such as the table that it was being scanned on. Getting rid of the extra information is very easy. I can just pick out the areas that I want to keep, and I can easily remove all the rest of the information. Once I have this piece here, the next thing we'll do is we'll break the scan data up into some different areas based on changes in curvature. And so you can see the different colors applied to the object now. This lets us understand a little bit more about what's happening with the part. And I'm going to use the scan data to help me build a section that I can draw against. So you can see this blue outline here shows me the outline of the information that we've captured. And I'm going to use that to help me build my model. So I can very easily draw up what should this thumb wheel look like, complete with tolerances and clearance. You can see that that's going to clear both sides. It extends to the scan data there. And where it terminates in the part is more or less a guess, but I don't have to be very specific at this point. Once I have that information, we're just going to do a revolve and create the base shape of the thumb wheel. So now I have this thumb wheel, and I'm going to build a helix on which I'm going to build the rest of the part. So with the Smart Helix tool, we're going to use the vector and a starting point, and you can see it builds a helix here for us. And as I turn the scan data back on, I can start to see whether or not I'm matching the scan data or not. I can also plot the scan itself and see how closely I'm matching. And now I have a profile for this shape. So now I'm going to do a solid sweep operation to take that profile along that path. Now we see we have some twisting going on, so I'm going to define that it can't twist in a certain direction so that I get a perfect profile. And as I turn on the scan, you can see that I'm matching very closely to the original thumb screw, which may not have been perfect either. It may have been cast and then just highly polished. So I'm going to go ahead and add this information, and I'll have built one complete thumb screw. Now I just want to add a few more design points, such as adding in a fillet to round off the shape so that I don't have sharp edges on my part. So now I can see that I've got a very good thumb screw that matches the original wrench quite well. So I'm going to use this, and now I'm going to move on to the claw portion over here. Using the same process of taking a sketch based on the section of the scan, I'm actually going to take the total shadow of the part. And this is going to help me build this claw shape very easily. So again, you can see that I can very easily snap to the scan data points themselves, building the information that I need. Very quickly. Now I'm not entirely sure where the part stops inside the wrench, so I'm just going to make an assumption that it should stop somewhere near the top there. So anyone who's familiar with CAD and design and drafting should realize and notice that this is very similar to the process that you would use to design a component. So we typically call this reverse engineering or reverse design, where you're actually extracting the design intent from the part itself instead of just duplicating the original shape. So here I need to build this shape here, and I want to add a fillet, and I can modify the value of this fillet. So maybe it's 1.2. That looks very close to what I'm looking for. And we can start to measure some of the angles here. So if I measure that angle, I'll make it also 40 degrees to match the thumb screw. And I'm going to extend these pieces. And now I just need to pattern these up and down this claw shape so that they'll engage with the thumb screw itself. So I'm going to do a linear pattern of that shape. I'll just turn it. And remember, I set the pitch of the thumb screw to 5.65 millimeters. So if I type in that value here for the spacing, I get a perfect pattern that goes right through all the gear teeth. So I'm going to go ahead and accept that. And I know that up here, the part changes a little bit, and it just goes to a straight edge. So I'm going to go ahead and make that design change. And I'm going to add a fillet here with some additional clearance. So we can very easily come up with a complete profile and remove all the extra information that we don't need. You can see we have a large number of constraints on all of this, but this also preserves our design intent through the entire process. So we'll go ahead and take that information and we're going to extrude it in both directions. And we'll remove the excess material. Now I have a shape that I can extrude and remove material from the large block that I've made. Now I just need to find the shape for this area. Now I have the same shape that I can use to cut on both sides of the part. So we'll cut through all and we'll get the result like this. So now I can see the claw is mostly done. I only need to make one additional change, which is adding in this area. So I'll once again do a mesh sketch with the outline of the part, and I'm going to fit again right to the scan to help me build this shape. And then I'll extrude this. As I get close to the correct length, it snaps onto that area of the scan data and tells me what the value should be. So I'll go ahead and extrude and merge that together. So now I have two of the three components finished, and these are the components that have to actually interact with each other. So now I'm going to concentrate on the main handle of the wrench, and I'm going to continue to work the same process that we've seen already. So I'm going to go ahead and extrude this, much like before, in both directions. And then my next step will be to find the profile that takes up the entire outside shape. So here I have the outside shape, and again, move on to cutting the part. So now I have the majority of the wrench shape complete. We only have a few details left before we can make a functional model. So I'm going to go ahead and cut out some of the information for the claw and the thumb wheel, and you see I get this cut information that cuts away all of the extraneous information and gives me the correct profile. And again, comparing with the claw that we've already designed, we have plenty of clearances, fit, and function. The only things left now are some additional detailing, as well as some fillets and other things. As I add some fillets to the part, we can easily measure the radius from the scan data. And add that information. We can also apply a radius to the inside of the hole, finding it to be a little bit smaller. Some of the additional features that we need to do are cut out a pocket here to reduce the amount of material that we're going to use, or we could choose not to. And then the original part had rounded features for these two areas, and we can add those rounds there. But otherwise, the part would then be ready to go to printing and ready for actual functional use. Here we see a Solidworks motion simulation showing the function of the part prior to going to printing.